initiative aims to raise awareness among students about India's achievements and opportunities in space sector while promoting space education, scientific awareness, research, innovation, and engagement with emerging space technologies. The celebration has already been commenced since 14th August through an essay writing competition on space technology in India, witnessing enthusiastic participation from around 40 students, and they provided opportunity for academic industry interaction and meaningful engagement with national space ecosystem while strengthening Amity's space mission and its contribution to India's growing space sector. Today, our workshop, with everyone's permission, can we start with the workshop? Good afternoon, everyone. On behalf of Amity University, under the visionary leadership of our Honorable Founder President Sir, Honorable Chancellor and respected Vice Chancellor Madam, I, Kamakshi Parsai, a proud member of SNT War Room, extend a very warm welcome to all our distinguished guests, esteemed speakers, faculty members, researchers, scholars present here today. You will be pleased to note that Amity Space Mission is being pursued in a comprehensive and focused manner across all Amity universities and international schools through the efforts of FSTR and SNT War Room under the esteemed guidance of our Honorable Founder President Sir. As part of this endeavor, we are delighted to come together today for the workshop From Earth to Space, Exploring Our Future Beyond Earth, being organized as a part of India's Space Week celebration in collaboration with Indian Space Association. We are also very pleased to mention that one of our valued partners who will be soon joining us, Mr. Prakhar Jain, founder and CEO Synodic Space Education, who has come forward to engage and train our students in rocket motor and propulsion system, giving you the practical exposure to the exciting world of rocketry and space technology. I would now request all the dignitaries to please come on the dais. Dr. K.M. Soni sir, Dr. Sanjay Singh sir, Shivani ma'am, Sanal sir. Please give a huge round of applause to all our dignitaries. As Amity continues to make remarkable strides in space exploration, innovation, and technology, today's workshop provides us with a unique opportunity to learn from the eminent experts and visionaries who are shaping the future of space science and technology. Let us begin this exciting journey beyond Earth. To formally commence today's program, I would like to invite Dr. Sanjay Singh sir, Director, Amity Institute of Aerospace Engineering and Amity Institute of Defense Technology, also the Chief Coordinator of today's workshop, to deliver the opening remarks. May I request you, sir, to please address the gathering.
Good afternoon, everyone. So now you know we are celebrating birth anniversary of Dr. Vikram Sarabhai ji, and he is known as father of Indian Space Program. So as part of this Space Week, we have planned this workshop, and as part of this workshop, so we have planned 4 sessions and 1 live rocket launch demonstration by Synodic Private Limited. So first session will be, my faculty is sitting here. So first session will be conducted on rocket, spacecraft, space tourism, and human life in microgravity. Professor will be conducted by Professor V.R. Sanal Kumar, and he is also ex-scientist of ISRO. The next session will be conducted on next generation space system Convergence of AI, Digital Twins, and Quantum Technology by Dr. Shivani, Professor, Amity Institute of Space Science and Technology. The next third session will be conducted by Dr. Basant, HOD, Mechanical Engineering, on water generation in space station. And the fourth session will be conducted on rocket motor and propulsion system by Mr. Jain, founder and CEO, Synodic Space Education. Thereafter, we have planned a live rocket demonstration in the main grounds. So objective of this conference is very clear. That is to motivate students to take up the research in the field of space, aerospace, artificial intelligence, and relevant fields, so that based on your research work, you can join research organizations, defense organization, and you can contribute in the Indian space program and in nation building. So this year I am pleased to tell you this year our three students of BTech plus MTech program, they have joined Skyroot Aerospace and they were the part of this Vikram 1 team and they contributed in this Vikram 1 launch mission, which is launched by first private organization in the country. So based, if you take up the research in this field, okay, so based on your research and based on your, because we have in aerospace very active aero modeling and rocketry club, so you can learn the required knowledge and you can develop the required skills. So based on your research publications and your knowledge and skills, then definitely you will be able to join these organizations and you will be able to contribute in the Indian space programs and defense organization. So with this, so I wish you all the best for this conference. Thank you.
Thank you, sir, for your inspiring opening remarks and setting the stage for today's fascinating discussions. It is now my honor to invite Dr. K.M. Soni, sir, Professor and Deputy Dean, Engineering and Technology, Amity University, Uttar Pradesh, to deliver the welcome address. May I now kindly request sir to address the audience.
Thank you, Kamakshi. A very good afternoon to all of you. Students, good afternoon. Yeah, it's better. On behalf of most respected and beloved Founder President Dr. Sukhdev Chauhan, Visionary and Dynamic Chancellor Dr. Atul Chauhan, Vice Chancellor Dr. Balendra Shukla, and also on behalf of Domain of Engineering Technology, I welcome you all to this important workshop for final year students, scholars from Earth to Space, exploring our future beyond Earth. It's a part of the celebration of the India Space Week in collaboration with Indian Space Association during 14 to 18 August. I would like to welcome all speakers on dais. They are our colleague, Dr. Sanjay Singh, B.R. Sanil Kumar, Dr. Shivani Verma, Dr. Basant Sakarwar, and also especially Mr. Prakhar Jain, founder and CEO, Scientific Space Education. His session would introduce students to the fundamentals of amateur rocketry and covered various topics, such as basics of rocketry and rocket flights. And you can see on the slide, there are many aspects he would be going to cover. At AUP Noida, we have been organizing many such events, conferences, seminar, technical, non-technical events, and workshop for the students since its inception, and will continue to do so for overall development of the students. We believe in outcome-based events and activities, and will try to organize events that promote the holistic development of the students, uplift society, and in turn, the nation. Last but not the least, I congratulate the organizers, especially person from STIF, FSTIA, and SNT War Room, and also Domain of Engineering Technology. And thanks all the students participating for the participation in this workshop. The event is successful only if participants benefit out of it. So I request that all the participants take full advantage of this wonderful workshop which are going to held. Thank you.
Thank you, sir. Thank you very much for your encouraging words and for highlighting the importance of knowledge, innovation in advancing the frontiers of space exploration. Now, we move to the first technical session of the day. To deliver this session, we have with us Professor Dr. V.R. Sanal Kumar, sir, from MIT Institute of Aerospace and Engineering, to deliver this session on the topic rockets, reusable spacecraft, space tourism, and human life in microgravity. Please join me with welcoming our Dr. V.R. Sanal Kumar, sir.
Good afternoon, everyone, and respected dignitaries on the dais and off the dais. With the permission of the management and founder chairman, I would like to give a small talk here, possibly half an hour. Just now, director was advising me, you can take a little more time because students may be interested in the talk. Yeah, my PPT is Sanal. I think that one. This one, yes. Since I worked in Vikram Sarabhai Space Center, I think it is my privilege to commemorate Dr. Vikram S. Sarabhai. He was a director in VSSC, one of the centers of ISRO. Initially, it was called Tumba Equatorial Rocket Launch Station. Later, it is named as Vikram Sarabhai Space Center. So look at it. He's a father of Indian space program. So that's a given his picture. At a young age, he lost. My talk is focusing from Earth to space, exploring how future beyond Earth. We have to ask why we want to go to space. That's a fundamental question. So I'll be addressing that in this presentation. Now, coming to the evolution of aerospace engineering, you can see that 1500 Ornithopter, then you can see the Wright brothers, then we can see the aircraft, subsonic, supersonic, hypersonic, you can see including our flying car, space shuttle, everything has evolved over the years. Now we are planning to go to another planet and create colony there. So why do you want to go there? And what we are not available in Earth. See now look at the planet. Our solar system is not just the 8th planet. It's a vast gravitational domain extending far beyond the planetary frontiers. So very curiosity. Even I don't know the boundary of our space. And many people are talking so many stories, but I still not believe what is the boundary of the space. See the solar system again. Look at where are we? You can see that we are here. So we are from here. We are traveling to another planet. So what we are going to gain by going to another planet? That is the question of the day. Look at here, NASA. This is a source from NASA. They've taken a picture from the moon. This is our Earth. So this is 24th December 1968. Human beings saw the Earth rising above another world for the first time. Today we ask, where do we go from here? Can humanity become a civilization beyond Earth? So that will be a very important and interesting question to all of us. And now we started developing multi-stage rockets. And US and other space agency already having a space shuttle. And we are in the process of making a space shuttle in the future. So why do we need space? See, survival, curiosity, knowledge, health, economy, and human aspiration. Why should humanity remain a single planet species? Why do we want to go? Again, the question arises. So Earth is where humanity belongs. space is where humanity can expand. So we want to expand. So we go to space to expand the future of humanity. And we do not go to space to abandon Earth. We will retain Earth as our homeland. To get here, so we will be flying from here to another planet. What you are going to gain? So preserve, sustain. So we need to survive. We need to discover new things. We need to progress. We need to expand. So what type of expansion we are going to do in other planets? So why go beyond Earth? See now, coming to the main topic of here. See the visionary who looked beyond the Earth. As I told you that, the father of Indian space program. If we are to play a meaningful role nationally and in the community of nation, we must be second to none in the application of advanced technology to the real problem of man and society. Second to none, I mean first. So that's what in all the classes I used to say that you should always think out of the box. We should be the first in the world. Then only we'll be able to develop new technologies to the humanity. So we should always look at here. It's too early we left. So that's he was in 1990 to 1971. So he died in that one. Now look at here. It's very important. All of us faced the COVID-19. That time everybody was asking, if we are having a lockdown, by that time if you are having a space shuttle, we should have been go to the another planet and lived there for 6 months, then come back after the COVID over. So that means when last year I was in NASA, when we are talking that why do you want space research, why do you want to make space shuttles? Whenever there is a calamity happen to the Earth, anything happen, not only for the COVID, any calamity happens, immediately we can take a flight to another planet and live there. Why do you want to go there? You want to survive, you want to have a healthy and a lifespan, high lifespan, you should say. So we will always for the survival. So this is what we are always looking for. Whenever there is a calamity, we can find an alternative home, that home away from home, another planet. You can think of it. No self-sustaining human community exists beyond Earth yet, so that we have to make it. That means, listen, a tiny virus can create problems to the Earth. So that means anything can happen in the future. So we should be always curious and prepared for the future. Now, what best we can do for that? So I used to tell in the classroom also, so imagination is more important than knowledge. Knowledge is limited. So this is not my words. Albert Einstein has mentioned years before. So knowledge is limited to all us. We know that and understand, while imagination embraces the entire world, and all there ever will be to know and understand. So we have to imagination more. Rather than textbook equations, equations will not help you. I used to say when I was in ISRO, we never open the test book. We will do the test results and design the rocket. If you go to the test book and equations, our motor will be failure. We have seen a series of failures. So we should always look for the natural thinking and the natural experiments and natural thoughts. So without that, we cannot develop a new vehicle to land into another planet. Because all the theory developed so far based on Earth systems. So microgravity condition totally different. So we need to have out-of-the-box thinking and new innovation. Look at here, the thinking for this. E is equal to mc squared, all of you studied. So this says that energy and matter are convertible. If that is the case, we can convert matter into energy, again energy into matter. Why do you want rocket propulsion? If you are able to make that, so we can transfer from here. That is popularly known among the school children, that is teleportation. So we need to think about the options for energy and matter converting each other and recovering to that. So we can fly. Without matter, we can go to another planet and get back to our body shape so that we can live there. So that is an hypothetical question, and so far nobody has come up. So now this is a provoking question. So that a fantastic question for a young mind in the audience. So we are going to spaceport. So your entire body becomes energy waves, and it is passing through, and it is reaching to another planet. There, if you are able to come up, you can see this E by C squared. So this, you'll be able to convert your entire body. But where is the life? So when energy and matter is defined, something else has to be defined. So we always say that God. So something else, unknown is there, so we need to surrender to the God. So that was a life. If you want to get matter, we possibly will be able to convert. But what about the life? So that is beyond our comprehension now. So physics possible in principle for practice, but technology far beyond the current capability of complex object. The human teleportation, it is still speculative. So that is what this is most of the media will be saying that if you can natural cut and paste, so we can initiate and we can terminate. So we can transfer from person, satellite we can convert to energy and put it into orbit. There, if you're having a system to convert to satellite, there is no need of rocket. So that is rocket technology will be collapsed if you're able to come with a concept of this. Now, this is something we are all discussed. Now, curiosity, what is required for this? Since this audience, when I was discussing with the director, he said the audience are mainly students. Then I thought to prepare the slide so that to create some curiosity. See, I seen once mentioned that I has no special talent. I am only passion to curiosity. So students should have the curiosity to, you should always ask questions. Answer can be wrong, but questions will never be wrong. You should always raise questions and get it done. So curiosity ignite questions. Questions drive discovery. Discovery shape the future. So that means you need to create questions, ignite questions, so that you will one day you will get the correct answer. So that solution will be there. Now look at here, from vision space to the living in space. So now we are looking for we are developing multi-stage rocket. So we are planning certain destination. Now we are planning to leave some planet habitat. Then what for? So we'll be able to get economy, the business. So we can plan of a business with the economy. So a lot of applications for the industry in different planets. So our goal is not just to visit space, but to make it for our new home. Now look at here, we are having experience with microgravity, our own Indians. So you can see that SpaceX Falcon, so Shubhangu Shukla has visited in the space, and very recently, 14th July, Anil Menon was Russian soils. So he's carried out a lot of biomedical research there. So it is possible that we can go to outer space and do experiment, and we can see the possibilities of living in microgravity in future. So when we are India start evolving the rocket technology, so sounding rocket, we worked in sounding rocket. So ASLV, augmented satellite launch vehicle, then polar satellite launch vehicle. So geosynchronous satellite launch vehicle. Then we are having a LM3, Gaganyaan. Now this is going on. Now our next target is to space station. So we need to build up space station. So young minds should start thinking about how to develop a space station in another planet. This is a typical question I used to ask in the students in the classroom. Earth is rotating 12 hours. Normally flight to USA is 18 hours. Why do you want to fly? Without flight, can we go there? Now that is the question now. So within a few seconds, we can go to outer space, take the space shuttle, route 90 minutes on revolution. You can have around an 8 to 9 round you can take there, then come by as a re-entry vehicle, so that you can have a space tourism going from India to USA. First go to space tourism, then land there. So you can have you can see here, the international journey can be just from the airport, Indian airport, go to outer space, space travel, tourism, then coming to the destination at the US airport. So you can very easy, that concept can be worked out in future. So that's a very big business model for the future. So why we spend 18 hours? That is a question. So we can save the fuel, we can have the space tourism, and we can invoke for technology is required. What type of technology is required for making this concept into true? That young mind can start thinking about it. So now look at our India is already developed the multi-stage rocket, so LM3. Now we are going for the high power rocket and also the Gaganyaan project in the near future. Look at here, now the question of reusability. When we are starting with the business, so whether we can use the same rocket for multiple times, reusability, how can we reuse the rocket? Space already come up with an idea. In our own students already come with some idea. I will show you some of the slides there for how they developed it. So how can we reuse it? After launching, we recover it so that we have to have a soft landing on the Earth. So we can use the same rocket multiple times. So that will be reduce the total cost of the flight. So tourism can be invoked. Now look at the global orbital launches. This update only up to 2024. You can see this now trend is increasing. So aerospace research and industry trend is getting high. So that there's a good scope for aerospace students to develop new engines or new technology. So this slide I purposely take because these are our own Amity students. When they were first year, they came to me and talked to me, and they said they will design a rocket for reusable. You can see this reusable rocket and sustainability. This is carried out by the now current third semester students. It is accepted by AIA. And see the horizontal landing here. After completing the target, so it is taking back to the earth, the horizontal landing, you can see this touchdown this. Now. So we'll be able to come with this type of innovative idea, industry will be taking and they will be sponsoring for that. So students who are sitting here can start thinking that what is the best way to recover the rocket. All the stage, not only for first stage, normally people are looking for the first stage, second and third stage also we can recover the re-entry time. The heat transfer is the major issue. So how to reduce the heat transfer? That technology also developed. Our own students having published in some AA papers. So they will be able to reduce the aerodynamic heating through this, avoid the shock and aerodynamic heating over the surface of the aircraft. So we'll be able to recover and safely land on the surface. Now look at here, what best we can do. So we need to have some simulation technology and static test. So we'll be able to come up with a reusable rocket launches. So future research and validation roadmap, it is in your own hand. So you can start working on this project. So now this is another technology developed for reusable, this electric assisted descent. So how we can take this aircraft safely to the land. So this electric technology is also there. Multi-purpose propulsion system also we can develop. Now, space tourism, you can see this is what is our main focus of this agenda. So you can see this starting from here, the first generation. So second generation, you can see this, we can travel to the orbit, you can sightsee. So the third generation, you can see the research. Then fourth generation, we can do for the industry and economical aspects. Tourism may be the first consumer-facing application of a much larger space infrastructure in the near future. We can see this, how we'll be able to achieve this target in the near future. So industry or sponsors maybe come up. If you come up with a new concepts model, there'll be international sponsors will come and help you for giving you the startups. Now you can see this unused capital. Normally the Indian economical system say that unused capital can be converted into the flexible, so that passengers will be using for this the capital. So you can use for the launching site. So it is converted into the various spacecraft, the reusable launches. Then we'll be able to do for innovative research, multiple programs. You can see the research, manufacturing, and everything can be carried out through this. And the production and space economy we can also increase. So space tourism may look at the luxury consumption today, but later can be for any government can go to outer space. Digital world will come the space enabled world. So that is what our future plan for this. So space will be controlling the complete world. Now we are talking about the digital world. In the future, it will be space enabled world. Everything will be there. All this product and process will be taking place, and we need to come with a new concept model so that we'll be able to achieve this target in the near future. Now, the space manufacturing, another important area that we can look for this. So potential areas for advanced material, pharmaceutical and biological, and as well as optics. So a lot of applications are there. You can see this, we can make it. So we can make some product there in the outer atmosphere or microgravity conditions and take it back to the earth, and we can be for useful purposes. Future of space may not be about the bringing everything from the earth to space. It may be about discovering what is better product in the space. So Moon as our humanity's first off-world infrastructure. You can see this, whether India has already achieved to reach the moon. So later we can plan for a colony in moon, or we can have a second launching station from the moon. So we'll be able to work out for this cluster economy. That is a future economic ecosystem operating between Earth and the moon. So we'll be able to come up with a new model for the moon colony. So Mars, not just a destination. Can human establish a functioning community on another planet? So we can also go to the Mars. So ISRO is already proved that we can reach the Mars and we can create a colony over there. So not because it is easy, because Mars provide the next test. So we'll be able to plan for the Mars mission as well as all the other possible planetary travel. So reality is the big question now. Can humanity become a multi-planetary civilization? Now we are always thinking about Earth. We do not yet know the answer. So, but every generation that has expanded the boundary of the human habitation has made the next boundary possible. So let us see that multi-planetary civilization is there. So whenever there is a calamity, you can always look for a second home so that we can fly there quickly. So we need a lot of technological development. So space flight is not only an engineering challenge, but it is a biological challenge. So it is already proved that NASA studies are carried out, space agencies are given a lot of report. Very interesting that our biological system, sometimes blood circulation will be just reverse flow taking place in the microgravity conditions. So it depends upon the health conditions. So we can create a situation that human can live in microgravity, provided if you're able to create a system for the survival. So now we must say that the space, whether we need to combine Earth and space, that is, it is Earth is our home and space is our expansion. So not Earth versus space, but Earth and space should work together. In future, as I told you, instead of digital world, the space world will be coming up. So Vision 2050 and 2100. So we'll be looking for the making colony in the new planets. So we need a technology. We are already having the concept to reach other destination. So we need to have a new concept, new models, and new ideas so that young minds can start thinking curious questions. Always ask curious questions to get answers so that we'll be able to achieve this target in the very soon. We don't have to wait for the 2050, maybe well before that we can achieve that. So from Earth to space, the next generation of human civilization, it is explore, innovate, and survive and build, and that is for the future. So now this is a short presentation. So any question for this audience, you can ask. I'll be happy to address. So we need to couple the Earth and space together so that we should have a new model for the future. Please.
How far are we go to the reality of exploring the asteroid reservoirs? Was that always been a center of
Yeah, this is a lot of unknown things are there. If you're able to come with a model to predict, and so we will be able to work together.
That's true, sir. But actually, when I was in ninth standard, so the NASA used to organize that kind of a project or something which is related to asteroid belt and mining. So I took part in that. So at that time, we realized that whether ISRO is actively pursuing its projects to explore beyond the solar system, because when NASA is exploring, we can't let ISRO to be backside, right? So, like, what is your opinion on that?
Yeah, definitely. ISRO is looking to the ISRO is also looking for alien research also. So everything is within that space because most of the information cannot be shared outside. So once the project is accomplished, it will come out. So NASA has already declared that another planetary system is there, another Earth is there, but we don't have any scientific evidence as such. So we cannot make any premature comments in the public. So a lot of research is going on there, including.
Okay, sir. Okay, sir. So the last question is like I mean, like we had seen the news like how the Vikram 1 successfully took off from the Earth, and it was the first time where the private company had done a marvelous achievement. Do you see the entire India space market or the space industry? It's gonna be something a collaboration of public and private partnership model in the future, or is it present or is it reality? I just want you to.
Yeah, actually, that's a political question. I support public sector first, then private sector, because public sector, we are having enough manpower. So enough manpower, ISRO is having enormous manpower. So if you make use of the manpower, brain drain will not be happening because most of the people are leaving the ISRO. That's what I know. They are coming with the startup. I encourage startup. Definitely, I encourage startup because ISRO should be the public sector should stand us alone.
Thank you, sir. Thank you.
Hi, good afternoon. I would like to add a point. In addition to what Sanal sir mentioned, if you look at the developments that are happening around us, starting with, this private launch vehicles to very recent orbital, this launching capability. So everything is happening in collaboration. If you go through the news or if you are, keeping track of the developments, you can see that in addition to government organization, private startups and industries are also collaborating, plus academia is also playing a very important role. So I would say the current space ecosystem is working on a collaborative effort. That is the thing. Yeah.
Thank you, ma'am. Thank you. Thank you.
I used to say in the classroom, 40 students are there, 40 startups should come up.
Just to
40
add
new
on to-
ideas.
Just to add on to a point said by sir and ma'am, you must have heard about transfer of technology of SSLV to HL.
Yes, yes, yes.
Then there are tenders out for transfer of technology of PSLV, GSLV, and NSLV. Okay. So looking at these transfer of technology, I'm pretty sure that ISRO will soon become a completely research and development organization instead of being doing commercial launches. So ISRO's complete focus would be just research and development, while the technology development, doing commercial launches and doing commercial projects would completely lie on the backbone of private industry.
So because of like last one, basically what I have observed is that ISRO have done phenomenal job, like since from the satellite, because it's famous for satellite launches. But so it's very concerning if you just look at China, the USA, they are launching more satellites, more launches are coming up. So we were a situation where ISRO was only one agency who used to do satellite launching and also scientific exploration. So I felt that that increases burden on the ISRO more than enabling the players. But thankfully, government has opened for the private sector. But I wish to see ISRO as more as an technology enabler rather than being competing with the other private companies. So thank you so much.
Yeah, there's what my personal feeling is that R&D work can be carried out in ISRO. The project oriented launches, other can be private industry can do.
Thank you, sir.
Best brain can be in the ISRO. So other project mode we can work it in. I was in the R&D mode in Vikram Sarabhai Space Center. I know A to Z of the rocket design. So when we are having a rocket club started, I was suggesting that first fundamentals. If you have the fundamentals, you can redesign. Brevity will be there. Why aircraft designers are not making different? Because fundamental was missing. Even a supersonic aircraft, they don't have fundamentals. If you know the fundamentals, definitely we can bravely redesign the aircraft and rockets. So fundamentals now we are having. India is having the manpower, so we can develop better than the US systems. That
Thank
is,
you,
I am confident that.
Thank you, sir. Thank you so much. Thank you.
Good day, sir. My name is Rudra Garg. So you talked about manufacturing in space.
Yeah.
So, sir, my question is, so currently, what are the limitations we are facing for doing a large-scale project in manufacturing industries in the orbits of Earth or Moon?
Suppose if you are going to make a composite material, if you do it in Earth atmospheric condition as well as in microgravity, it's totally different. So we'll be able to make high strength material, high strength light material for even for the missiles and other things. So we'll be able to make it in the outer space better. That will have a product will be very high cost. So we can do that. Certain technologies are confident. Still, ISRO is working on it.
And so what about asteroid mining?
Asteroid mining, we are not, there is no separate division to ISRO as such. So if anybody is coming with a new concept and a new model, definitely ISRO can start a new division.
Thank you, sir.
You can always ask questions. Question will never be wrong. You can ask any question.
Good afternoon, sir. My name is Soumya Mishra, and I wanted to ask your opinions on the commercialization of asteroid mining and like commercial extractions of metallurgy on asteroids.
I welcome. That's a good idea. We can commercialize.
Sir, like the commercialization is like basically more a research-based thing,
Yes,
or
both. We need to research base as well as for commercial.
so is there any project or any
No.
upcoming thing that ISRO is achieving in this area?
If you are having idea, you can propose to ISRO through either startup or through the institution. Definitely will take into account.
Good afternoon, sir. Myself Dilip, and have two questions. One regarding PSLV. Since first launch, PSLV has been the most successful launch vehicle by any space agency. But last two has been bit missing their course, maybe because of the technical cyber attacks. So how the new threats for space tech is happening? This is my first
Yeah,
question.
that is purely a security question, and we are having a very high security tight is there. Even I used to say in all the students here, a person who is working in the space industry should have 100% integrity. Even a small technician can destroy a vehicle. So while connecting the igniter to the rocket, if you make some small difference in tilting or pressure, the rocket upper stage will fail. So that is, those who are having high integrity only allowed to go to the integration part. So there is a full-time camera set also there. Security that definitely is there. We need to take care of that.
Sir, and my second question is regarding human exploring beyond Earth.
Yeah.
Because biologically we are not yet ready to move beyond Earth. So are we not too much pressurizing on exploring human colonies beyond Earth?
Yeah, it is for survival. No, our own students, aerospace students are doing with the ISRO on space research or microgravity. I think on Dhruv Panjal and his team is working on microgravity studies on biological systems. So we have identified a no concept on this. Once it is success, probably we can give a solution, countermeasures. So what measures we can, or spacewalk also. Now we are all afraid for spacewalk because of the low pressure. Low pressure means our low pressure condition, all fluid will have the bubble formation. Bubble formation will create a sound decrease. Sound decrease means it will maximum can reach to the sonic condition. Sonic condition means it will go to supersonic and shock wave. That can create catastrophic failures to any flow system. We experience most of the cryogenic rocket failure in the pipelines because of the bubble formation. Same phenomena is happening in the cardiac, the circulatory system also. So our own students are working on that. That's what I said. We are having students better than IIT caliber students in Amity. I must thank to the director for that. He's retaining research environment. So good faculty and good students are getting here so that he can. There is no need to go to IIT or IC. I'm from IIC top university. I'm a gold medalist also. But I used to say that there's no need for talking about the gold medalist or the silver medal. So what is required is the fundamentals. Energy equation remains the same when you are solving the problem when you're sitting in Amity or in Stanford or IIT. So you don't have to go to run behind any university for a brand name. You can create a brand name here.
Thank you, sir.
Good afternoon, sir. I am Soren Roy. I wanted to ask about the Mangalyaan mission.
Yeah.
So we have currently done 3 missions on Moon, and currently there's a work on the 4th mission also going on.
Yeah.
So why in Mangalyaan we didn't do a second mission, that landing a rover on the planet?
So this is, we experienced a software failure in the earlier, and also now the government is asked us to stop all the launches until further orders. So now the inquiry is going on for the PSLV 1 and 2 failures, last 2 failures.
Okay.
Sir, actually, when we are talking about interplanet exploration and your low Earth orbit commercialization, tourism, and everything, we have to remember that previous when the space treaty was signed, 1960s space treaty was signed, that no such commercial activities must not take place in the space. So when the era of the closed contested government enabled space era has been transformed into a private segment or exploration of the entrepreneurship in the space area, do you think there should be a new treaty or a new regulations from the Indian side to define what exactly we want to do in the space commercialization activities?
See, government means you and me, not the, we cannot blame for any person who is occupying the office. It's a public interest. What is interest to the people? So government will take a decision. If you want to commercialize, yes. If you want to go for a creative colony, other side, now COVID time, as I told you now, there is a calamity comes. So that times where we go instead of lockdown. So whenever the need arises, government will take a decision. So government is you and me only. We cannot blame anyone.
I see, sir. Thank you, sir. Thank you.
Good afternoon, sir.
Yeah.
I'm Rashi. And my question is there we have photo res and reconnaissance missions like for surveillance using satellites for the target on Earth. So is there a way that defense and ISRO could work for like carrying ammunitions to space also and fighting from there like right and there if it
Definitely ISRO can work. No, nobody will prohibit it. ISRO can work. We are having intellectual freedom and wisdom.
Okay, last question. last question. One more question before this session. Then after this session, you can meet Dr. Sanal.
Hello.
Okay, so he is internal faculty, so you can also meet after this session tomorrow also, right? So this is the last question because we have time, we have to finish this workshop.
Sure, sir. Good afternoon, sir. My name is Athav Sharma, and my question is regarding that most of the Indian satellites that have gone regarding the geoinformatics or like the GIS sector. We have worked with NASA for the NISAR sensor recently, where we have worked on radar-based sensor. But we have so many sensors like LIS 3, LIS 4, but many of them do not have the thermal capabilities currently. None of the Indian sensor have the thermal capabilities for thermal imagery for even Indian meteorology and many other factors. Even thermal imagery can be used for many commercial aspects. So what is your view on that?
Definitely, if you're having an idea, you can come with a startup or you can give a proposal to the ISRO. Definitely, it will welcome idea.
Sure, sir. Thank you so much.
It's a challenging work. Okay. Thank you. Thank you very much.
Thank you, sir, for your enlightening presentation and for offering us a glimpse into the future of human activities in space. We have been joined by our valued partner, Mr. Prakhar Jain, founder and CEO, Synodic Space Education, who has come forward to engage and train our students in rocket motor and propulsion systems. We'll be giving you valuable practical exposure into this exciting world of rocketry and space technology. Request all the participants to welcome our today's guest and our technical collaborator for today's event. Please give you a huge round of applause to Prakhar Jain.
Okay. So our next session explores one of the most transformative intersection of technology and space science. I'm pleased to invite our brilliant scientist, Dr. Shivani Verma, professor in an Amity Institute of Space Science and Technology, who will take us through the groundbreaking innovations that are redefining the future of space mission and intelligence systems. The topic is Next Generation Space Systems Convergence of AI, Digital Twins and Quantum Technologies. A warm round of applause for our Dr. Shivani Verma, ma'am.
Thank you. Thank you so much, and very good afternoon to all. It's a pleasure being a part of India Space Week and discuss one of the most important topic that would be shaping the next generation space systems. I would like to start with a situation. Imagine there is a spacecraft that is going for a deep space mission and suddenly something goes wrong. So, what are the two scenarios? One is we wait for the ground stations on the Earth to analyze the problem and communicate back the solution to the spacecraft, which would obviously be consuming most of the precious time. Second solution is that the spacecraft itself detects the anomaly, simulates all possible causes, evaluates all possible responses, and then delivers the best option to the mission team. The second option is the solution we are envisioning for the next generation space systems. But before going for the next generation space systems, we need to understand what is the need for next generation space systems, why we need to go from conventional towards futuristic system. Here, I would like to start with the orbit. Long time, we have been considering reaching the orbit as a defining achievement for a spacecraft. That once a spacecraft reaches the orbit, okay, we have achieved everything. But nowadays, reaching the orbit is increasingly becoming the starting of the mission and not the end of the mission. As soon as your spacecraft reaches the orbit, it is expected, to analyze the environment. It is expected to optimize the power. It is expected to optimize the bandwidth. And it is also expected to understand how to communicate with other spacecrafts that are there in the orbit. So these are a lot of expectations that we are putting on spacecraft of today. This is a paradigm shift. Not just that, when we are talking about future technologies, like I'm talking to you, you would be thinking, okay, ma'am is saying future technologies. So that would be coming in another 20 or 30 or 40 years. So I request you, please stop here and just look at the environment around you, look at the emerging Indian space system. Like you asked a question. So we are talking nowadays about private launch vehicle. We are working on hyperspectral imaging system. We are talking about space radar. We are talking about anomaly detection. So we are living in a very sharply increasing space ecosystem. So a paradigm shift is required. Conventional spacecrafts have to evolve accordingly. They have to move towards the next generation. And we are not stopping there. Look at our Gaganyaan mission. We need all the systems to be human rated. We are going for our own Antariksh station where continuous, long-term operational requirements are there. We are going for space situational awareness, which involves continuous monitoring of not only Indian satellites, but on our friend satellites as well. And not just that, we are moving towards constellation of satellite concept, which would be giving us lots and lots of data. That also explains why we need to move to futuristic or next generation space systems. And we are having Gen Z now, brilliant minds sitting in front of us who are having, very smart mobile phones in their pockets, who are reading about quantum in newspaper, who are getting direct access to satellite system. They need to think in terms of emerging technologies. You cannot afford to work or be expert in one technology in silo. You'll have to be expert in artificial intelligence. You'll have to be expert in digital twin technology, and you will also have to be expert in quantum technology. So generalist and specialist, both approaches are required from the brilliant minds sitting in front of me. Okay, so this is a slide that is showing how we are going for a different technology. Till date, we had satellites which are, capturing the data from the environment. The data is being sent to the ground stations. They are analyzing it, and decision is being made. But in the future generation satellite, we add understanding, prediction, and optimization as well. So it is not just capturing the data. We are not interested in sending the bulk of data down to the ground station. We want to understand, okay, what is important? Only that important part needs to be sent. We want to predict, okay, if this is happening now, what will happen in the next second or next millisecond? And we want to optimize, right? These three blocks, additional blocks, in addition to learning. I'm not going to behave like a dummy that I'm getting an input and giving the output. I'm also going to learn from it. So these are the things we are looking for in next generation satellites. And to achieve such a brilliant spacecraft, or to achieve such a brilliant space system, you need to have collaboration of different technologies, because it is not going to be a simple artificial intelligence problem. It is going to be a combination. It is going to be an integration of different technologies that will be helping us in prediction, in modeling, and optimization of the concepts. Okay, we are talking about very hi-fi things. We are saying that, okay, we should be having the spacecrafts or space systems who can, learn, who can optimize, who can predict. But what are the challenges? We are here on Earth. We are having every facility. We are having good computing power. You can get access to your GPU servers. We can have continuous connectivity. We can have lots and lots of labeled data. And we do not have any radiation induced challenges. But what happens out there in space? The environment is totally different. It is not similar to this comfortable environment on Earth. You can have communication bandwidth very limited. You can have very limited power available to you. Data might be less. You might go for, very advanced or very innovative augmentation techniques to build up your data set. So keeping in mind these challenges, this is a very good research problem for the bright minds sitting here, or for the Gen Z nowadays. You can look out for models which are very lightweight. You can look out for models which can be compressed and sent out there in space. You can look out for models who can work with limited compute and power capability, and also work with size, weight, and power available in the space system, right? Try to think in this manner. Please do not think that I am from maybe computer background or electronics background and I don't have a role in space sector, because nowadays space is an integrated system. Each and every discipline has a very important role to play. And we have accepted these challenges and we have demonstrated capability. ISRO is quite capable of this. So what we are trying to do, we have moved artificial intelligence very close to spacecraft. We are saying that, okay, a lot of time is taken when the data comes down and, the data goes up. Okay, no problem. We are having artificial intelligence on board, which computes there the required and delivers the result. This is one of the example, Indian onboard AI demonstration, where we are having AI on board, which is doing the required. Another demonstration, AI at the edge, intelligence in orbit, Dhruva's Leap 1, that is another example where the capability has been shown, and FISAT 2 by European Space Agency. So all these examples show that we can sense, we can infer, we can decide, and then accordingly act using artificial intelligence. Not just that, the government organizations like DRDO is also providing strategic capabilities, and they are giving us some difficult mission problems on which the students, researchers can actively work and come out with solution. Because space is being actively used in defense domain and space domain as well. There is no boundary to its usage. So that was a brief about how artificial intelligence has a role to play when we think about future space systems. Another technology I want to discuss is digital twin. So when we talk about twin, it means something very alike. That is a basic understanding. And this understanding is very relevant when you go for designing your future space system. So we have a real spacecraft, which is sending you data through telemetry. We are having power data, we are having thermal data, attitude, orbit, payload, everything is there. So what a digital twin is doing, it will be making a model of that system. It will be simulating all the situations, all the scenarios. It would be monitoring, plus it would be predicting as well and optimizing as well. That is a beauty of digital twin technology. And this is just a basic explanation. You need to go through different stages. Like I said, for every physical existing system, you make a model. So that is called digital model. You make one step ahead, you go one step ahead, you go for digital shadow, in which the data also gets communicated to that static system. Finally, it goes one step ahead, it gets matured as a digital twin. So when it is a digital twin, it goes for bidirectional data communication. It starts interacting with the model. Okay, the next step is predictive twin. Here we are combining, we are integrating artificial intelligence with digital twin technology. So that is what I meant when I said that integration or convergence of technologies is required when we are to go for futuristic space systems. And finally, not just the predictive twin, we can also go for mission twin, where it is not just interacting with the spacecraft in a bidirectional manner, it is also interacting with the complete environment. It is also interacting with other spacecraft that are present out there in space in its close vicinity. So that is a concept of digital twin. And here also the students can opt for number of research problems. Like you need to maintain the synchronization, you need to maintain the standards. Like I'm working in IEEE Digital Twin Standards Group. And we are working on how to develop operable standards between different digital twin of Earths present on this Earth, right? So that is another research problem for you. Like I said, if we are converging artificial intelligence with digital twin technology, we can make our twin very intelligent. It will be very useful for our spacecraft. Okay, so we have discussed, okay, we want something to learn. We have artificial intelligence technology. Then we said, okay, we want a model who should work similar to my system and predict the next step. So we have digital twin technology. But what if the data itself is a problem? What happens when the data becomes too complex, the problem statement becomes too complex? Because we are saying that, okay, we are going for constellation of satellites. We want to have anomaly detection as well. We want to have more autonomous system. But then the complexity would definitely increase, right? How to optimize that complexity, how to make it a doable problem? We approach quantum technology for that. So that is where quantum technology steps in, where we can have a new toolbox for optimization and also for taking care of other problems. Because we are talking about space. In space, the signals can be quite weak. So there we can go for quantum sensing. We want communication to be very secure. We can go for quantum communication. We want the trajectory path to be very optimized, right? We can go for quantum techniques for trajectory path planning or navigation. And similarly, we have very efficient algorithms which can do lots and lots of computation in very less time. So we can go for quantum computation. This is another research problem for Gen Z. You can pick up research statements from this domain and work on it as your major project. And this is also a new statement, not a new paradigm. We are already having a very established quantum ecosystem in India. We are having a national quantum mission. We are having 4 nodes. We are having a number of government organizations who have achieved something in the domain of quantum technology. Yeah. Going back to the original problem from where I started, we were imagining a scenario where the spacecraft is going for, a deep space mission and suddenly the things go wrong. If I take the same scenario in 2035, and if we are considering convergence of technologies, this is a solution I propose. We sense the anomaly detection, we have AI to detect because it will be analyzing the patterns. We have digital twin technology to simulate all possible causes. We go for quantum to optimize. We are not concerned with the complete data. We go for quantum for optimization. Further, we go for, again, intelligent methods to rank the possible responses. Our digital twin model to simulate if the response is good, and finally, the spacecraft to execute it. So this is the beauty of convergence of new technologies, which can make our space systems or spacecraft very intelligent and quite capable. So we have a long, long list of achievements we have planned, but obviously the timelines and milestones cannot be achieved on their own. Technology is required, like we just discussed. And to have that developed technology, we need researchers. And for researchers, we need very brilliant minds. So there are a number of brilliant minds sitting here. So I would say that instead of thinking that what job I can get in the space sector, please concentrate on what problem of space ecosystem you can solve, right? Like I said, every discipline has a role to play in integrated space system. So the next generation space system, it might happen in, it might not happen actually in a national laboratory because we are going for privatization. It might happen in a university lab. It might happen as your research problem, as your major project, or it might be you who is developing the next generation space system. Lot of problems are there. You can pick any one of these problems, take it up as your major project, a research problem, and you can work on it. Again, this is about how the students from different streams can contribute. If you're from electronics, you can look into, sensors, communications, avionics. Computer science can work on mission software. Robotics, they're expert in developing autonomous system. And number of other options are there. So the opportunity is already there. It depends on you how to bag it. Yeah, thank you so much. Your questions, please. Yeah, I was expecting.
Ma'am, so well, actually, like have done my BTech in AIML itself, to be honest.
Very nice.
And but the main issue is that if you wanted to get into space sector, especially the space innovation ecosystem, for example, let's take application of digital twins in the for the spacecraft optimization or also for any other purpose, there is a significant gap like what you're learning and how you want to apply in a spacecraft or something. So that is quite a missing, ma'am. Because for a student, for me, I just learned software. But if I want to apply that software in a working principle for satellite or for any space up vehicle, that is very difficult, ma'am. So how do you mitigate this, or how do you bring this curriculum programs to ensure that students are learning both together? Because after all, what I believe in the era of 21st century, space is multidisciplinary. Now, I don't think it belongs to one aerospace engineering students and that you learn, that's enough. So as you said, there's a lot of application, but I would believe that even the academia need to come step forward to make sure the space also remains interdisciplinary so that student can get exposure to all those technologies or whatever you wanted to choose it. Ma'am, the last question is,
Let me answer this question.
yeah, yes,
Yeah.
yeah.
So, like I said, space system is going to be an integrated system, right? It won't be the task of one single person. It is going to be a teamwork. So when we are working in a team, it is not the responsibility of one person or one student to develop the whole system. So we take artificial intelligence model from you. You work on the data set. So you are not concerned with spacecraft constraints. You're not concerned with the propulsion system. But yes, you are concerned with the data that is being provided to you, analysis of data, and to find out, for example, if there is any anomaly, right? So that would be your task. We place your artificial intelligence model at an appropriate point in the architecture, and rest of the things would be accomplished by the team. So that is how things work, right? You can always be a part of space system design without having explicit knowledge of the space system. It can always be done. But when you're working in a team, you gradually come to know about the different aspects of the problem statement. I mean, yeah.
So the second question is, ma'am, like basically the government has announced 1,000 crore Antariksh Venture Fund from the INSPAC, like the Indian Space National
In space,
yeah, in
right.
space. So, ma'am, basically, do government also thinking about launching dedicated, simulation labs or any testing facilities if you wanted to go beyond the solar? So, for example, if a private company or startup wants to explore the asteroid belt in mining, we mind that the space environment is very complicated and it is completely different than compared to like you just go beyond the solar space ecosystem. So, like, is the government planning any futuristic labs to simulate that environment for these startups so that they can iterate and redesign this space systems which can survive in the extreme and condition during deep space?
Yeah, actually, government is opening lots and lots of options. If you go through the website of InSpace and if you look at the opportunities, go through the dashboard, go through the list of opportunities, there are so many things on which you can work, not only as a startup, as an individual as well. Once you're granted the project, you can open a startup. Not just InSpace. Even the defense sector is providing lot of options to you. TDF, that is Technology Development Fund from DRDO. It is releasing number of problem statements relating to space sector. IDEX is releasing number of problem statements related to space sector. The only thing is you have to come up with a good innovative solution. You have to work on it, show the TRL level, how it is going to mature. And yes, you get the project, you get going. I mean, it is required from your end to do some hard work so that the organization is convinced that, okay, this person or this team, not a person, a team can work and you'll get the project. It is not a difficulty. This is the best time for research. I mean, you can explore anything and everything. Yeah.
Got it. Thank you, ma'am. Thank you.
Any more questions?
I just want to add to Dr. Shivani's point here. You're talking about that if infrastructure is available for high level simulation research and everything. And honestly, what I believe is that InSpace is actively working towards opening such infrastructure. And many of such labs have been already opened in Ahmedabad and Bangalore in the InSpace centers. So where you can directly apply on the InSpace website that this is the project which I want to do, and these are the things which I want to research about. They would give grant you permission. You can, with a very minimal fee, you can go at the facility and operate their all the resources which are available. And if needed be, and if your project has scope, has feasibility, and InSpace would definitely, and InSpace does not have the facility, they would help you get the permissions so that you could use the labs of NAL or let's say DRDO or ISRO.
They also provide expertise as well. I mean, they are ready to share that also. If the, if the proposal is good, if you get approval. Yeah. Yeah.
Good afternoon, ma'am.
Good afternoon.
I have a question regarding the digital twin technology that you talked about. So we talked about that it is bi-directional in nature, that it is not just real time. So how do you architect this spatially so advanced technology with 3D modeling and all of these pipeline alongside as if, how do you say it? How do you architect it along with all of these modelings and removing the latency bottleneck? Because we are talking about bi-directional. How do you remove this latency issue that comes in between updating the data?
Okay. First of all, it is not a 3D model. Please be very clear about it. When we are talking about digital twin, it is not something that a physical model is standing in front of you. Wherever required, physical infra is also the requirement. But digital twin is, I'll try to give you an example. If you are launching, take the case of healthcare systems, right? You're having a patient, you want to administer some medicine, but then you're not sure about it. So you make a digital twin model. So you're not making another person, right? You're making a software which is having the vitals of the patient under consideration, on which you will administer the different medicine compositions, and you will check if this works, if it doesn't work, right? So that is a concept of digital twin model. And if we are talking about latency, so that depends on the design, like what algorithms you are using, what software you're using. That is completely an algorithmic problem, right? And what else?
Yes, ma'am, that was it. The temporal based aspect was only the problem.
Okay, so temporal based latency can be reduced if you're going for good models. That is your algorithmic issue. That is not a system concern, system engineering concern, right? Yeah.
Thank you so much, ma'am.
Hello.
That's
So,
it? Okay.
ma'am, over the past few years, we have witnessed like a paradigm shift from, regular algorithms to, from human in the loop to more autonomous decentralized systems, right? And this transition is actually taking a lot of time, and we are seeing it across drone swarms, satellite networks, etc. So the thing is, whenever you're going for development in these kind of things as a student, it's very hard to access the right kind of data and venture in the right direction. So if I were to give an example, for example, with routing algorithms, like for communication between various nodes in flying ad hoc networks, you have very a large amount of open source options, but very few that actually target the real issues like latency or proper coordination or role assignment or prioritization of which task to take. So that is one question on how can we identify the right papers and content for that. Another question I'd like to ask is, like, currently in the Indian education system, we all know we are very focused on academics and normal paper stuff. Whereas if we see the main gap, if I were to say it that way, from my limited understanding and exposure, is that in China, in USA, we have very experiment and, action focused, as in they're focused more on building things rather than the raw academics and writing stuff in papers, right? So shouldn't we also be transitioning towards something like that? Because it seems we're still stuck up in a post-colonial mindset in this aspect. And if we want to reach the levels that we are aiming for, shouldn't we transition to a more build and experiment oriented mindset where we can create new things consistently and experiment with stuff? So, and how can we continuously collaborate with existing small scale companies to get better exposure.
I lost track of your questions, but okay, I'll try to answer it. Too lengthy question. First thing, you were talking about human in the loop, right? So when we are talking about artificial intelligence system, please remember that we are not replacing human beings, right? Please sit down. We are not replacing human being. It is just that the relation between the machine and the human being has changed now, right? So it is like you are developing one intelligent system. We put it at an appropriate position in your architecture, but we keep the validation with us, right? So there is always human in the loop at some or other point. That was your first question, I suppose. uh, is it okay? Okay.
So you can discuss after this.
Okay.
Because we have live rocket demonstration, that should be on time. Okay, we have limited time,
Maybe later.
right? After
Thank you so
presentation,
much.
only 3 questions we will take.
Thank you, ma'am, for such insightful session highlighting how emerging technologies are reshaping the space ecosystem. Moving forward, I would like to welcome Dr. Basant Singh Sikarkar, Head of Department, Mechanical Engineering, Asset. The session is titled Water Generation from Dehumidification of Air in Space Station.
Thank you.
Yes.
So, very good afternoon, all of you. I think, first I would like to thanks to organizing team for organizing such informative and very intensive workshop,
Yes.
especially for a space applications. So, go in a presentation. One thing I would like to be repeat again. Dr. Sanal already told you. Fundamentals are very important. I think you have a questions how we have to be connect to a academia with industries, or how we have to be go for a more and more kind of a I'm said experimental kind of a thing. So you know that engineering, especially that kind of streams where you have to be a more and more focus on a labs. So you know that every subject has a labs. So if you are more focused on a labs, definitely you have an answer of your questions. So thanks. I think first I would like to give a brief introduction myself. So I am a Professor Basant Singh Sikarwar, heading the Department of Mechanical Engineering. This is the part of MIT School of Engineering Technology. People say that ASIC. I think you are familiar with the ASIC. So my postdoc from Iowa State University, USA. I was there more than 4.5 years. After then, I joined MIT University, Noida. I obtained my PhD from Indian Institute of Technology, Kanpur, same like Professor Sanjay, and my master's from Indian Institute of Technology, Roorkee. So this work that I am going to presenting is a ANRF projects, basically where we have to be find out the alternative source of water production. And you know that air has a plenty of water in form of moisture. And same idea people are using for a space. How can we have to be generate the water in a space? So if you talk about the outline of this presentation, so because I'm not going too much technical things. If you have interested more technical things, you are welcome. You can come my lab and discuss most of the things. But here I'm going to the introduction where the challenges of water in a space. I think you have all of you have a questions, how can produce the water in a space when there is no humidity already. Then I will discuss about the cabin humidity. It is also very important. We have to maintain the humidity like a 50 to 60% in a cabin, not too high, not too low. So you have a pro and cons like this. Technologies, especially water production in space. So three most popular technologies that I would like to discuss. One is a condensation, then membranes and desiccant. Then global context. Basically, you know that Gaganyaan, our Indian space station, but international space stations, what is they have to use the process for water production or water generation. Then I'm talking about the Indian research like IITs, MIT, DRDOs, ISRO, what they are doing for in this direction. Then I discuss about the emerging route. That is a very interesting, if you see in this slide, MOF and next generation solvent. So this is the, you know that Department of Click Chemistry in MIT Noida, they are developing many kind of MOF material. And we have a joint collaborations with Click Chemistry to develop the new technologies, especially for water production in space. Then I'm discuss about the future outlook and takeaway. If you think about the challenges of water in space, right hand side, you say that crude daily mass intake of water 65%, 98% water recovery demonstration, especially this is a international space station, 98% they recover the water. Then 1 gallon per cube member per day, they are kind of a water consumption. If you say that especially for space, like water in earth is very easily available. There is a various methods you can get the potable water, but beyond the low earth orbit, especially for water production or water generation, means it is not viable operationally or economically, means these things is impractical kind of things. As I told you, like a NASA, they target the long duration tangent. Where they have to recover the 98% of the water. And demand and peer group, you know that suppose there is a 10%, so we need like a 380 liter water per day. So this amount of water we have to be produced in a space, kind of these things. If you go in a next slide, this slide is giving the complete environmental control life support system. Like if you go in a space station, so space station generally they have water recovery systems, they have air rehabilitation systems, they have oxygen generation systems, and this complete system is called like an environmental control life support systems. If you have talked about the Indian context, so you know that ISRO chairman, this is the previous ISRO chairman, Somnath, announced that the ISRO would be independent, develop the your environmental control life support systems for Gaganyaan. So they have to be working on this. So most of the IITs like MIT University, DRDO, they are, and space science, they are working about to be a development of the indigenous environmental control life support system. So here you can see that this is the technology, especially concern stone, integrate, manage air quality, water supply, essentially for a astronaut survival. If you talk about the source of cabin humidity, so you show that like a metabolic release by the crew, respiration and perception is the two most. Then moisture dissolved by the onboard items, like many items, they have to be evaporated like a water vapor, all things. Latent load continuously scale directly with the crew and size activity. So these are the main resource of the I'm say that moisture come from the cabin. And now the basic aim is that is, I am asking you, how can we have to be, because it is increase the humidity of the cabin. And as I told you, if you see in this slide, too dry and too humid, both are not useful. Even in a, you see in a earth, like you go in a Mumbai, where humidity, you are uncomfortable, or maybe you go in a Leh Ladakh, where the humidity is very low, you are again in comfort. So like humidity must be regularized, as far as human comfort, kind of this. So crew thermal comfort, equivalent reliability, and prevention of electrostatic buildup is very, very important. If it is too dry, like a low value of relative humidity, dry skin and irritated of eye, like this type of problem, static discharge risk of avionics, and degrade the crew comfort and performance. Other side, if it's too humid, microbial and fungal growth, that is the problem in a cabin. Condensation on cold surface and soft surface. Because somewhere you know that there is electronics cooling, all these things. So what happening, the moisture is going in a condensation surface which temperature below than to a dew point temperature. There's a condensation and this wattage effect on the electronics, all these things. And corrosion of structure and hardware kind of these things. So Gaganyaan, generally, if you see Gaganyaan, we generally temperature is 20 to 60 degrees centigrade and relative humidity in between to 30 to 70, not more than 270, not less than 230, but more or less we say that 50 to 55% is a more comfort kind of like this. If you talk about the why the water from the cabin airs, so I think you have already answer of these questions. So like we have to be a humid condensed resource of steams, not waste streams. So 1.4 liter we generally condense per person per day, and 4.8 liter is a per day of 3-member crew, like a 40 to 50 recovered by the up international space water condensation systems. So you know that maintain a humidity, we need a condensation. But same question is arise here. I'm talking to three technology, but before talking to three technology, think about how we have to do the condensation in a microgravity systems or in a systems where we have to be a gravity is very, very low. How many people are familiar with the condensation? Yes, please. This is a workshop, so I think, what do you know about the condensation? You raise the hand. Yeah. Yes, yes.
Sir, we're talking about condensation, right?
Mhm.
It is the cooling down of water droplets to.
Okay, good. So basically, you know that when there is a vapor phase, like if I'm talking in terms of the most air, so most air has a dry air and water vapors. And water vapor has some partial pressures. Clear? And corresponding, they have some saturation temperature. When the surface temperature below than to this saturation temperature, then there is a condensation will happen. Condensation is a two type, film batch condensation, drop batch condensation. And if you think about the drop batch condensation like a condensation rate, maybe I'm say that 20 times more than to film batch condensation. So people are more prepared to a drop batch condensation. It is more favorable condensation process. So here I'm talking to a three technology. One technology is a condensation. So like a cooling of air below than to a dew point temperature, drain the liquids like this. But question is this, how can drain the liquid when there is no gravity? So then this is again the problem. Then the membrane separations. So people have to be membranes. Selective vapor is transferred across this membrane, and this vapor is going to be a condensing surface and cool it. Then third one is like a adsorption and desiccants. So like binding the vapor in solid sorbent, and then we have to be condense it like this. So these three technologies are more and more popular, especially for a water production in a space application. So condensation and dehumidification, if you talk about the principle, so cabin air, this is a warm and a humid, like you have to be see in your home like a air conditioner. So air conditioner, when the like moisture is very high, you have to be a cold air as well as the your have a water kind of. So condensation heat exchanger, cooling below the dew point temperature, then phase separation, then water process assembly, then potable water like crew and OGC. So air is cooled only when the temperature below than to a dew point temperatures. So first things is because we need a efficient system, we have to recover the 98% of vapor. So we have to be think about to how can make the system is more efficient. Somebody asked about the AI, all these things. AI never replace the human. AI only have to be help to be improve the system efficiency. AI have to be give the direction where we have to be think more and more kind of. So AI, more or less, you say that the database tools. If you have a correct data, you have a more accurate prediction, all these things. So like this is the one process, condensation and dehumidification. This principle, you can see that you can get a potable water. What is the main difficulty or limitations, especially for condensation and dehumidification? High energy consumptions, because you need the surface which is cold and to dew point temperature, so you need energy. Then the operation complexity, like a coupled air, coolant, condensation loop, and active, all these things is also bulky and heavy hardware like this. If you have to use the condensation systems, cooling by the I'm say that vapor compression cycles, it is not easy. Clear? So it is not preferred, especially for a airspace. And microgravity condensation removal. This is the one important area. How can remove the condensate from the surface? Clear? This is a one important point you have to be see. So basically, you have to be develop the ductility gradient surface. They have a capability to be remove the condensation, even a microgravity. You have a cooling system more effective, not a vapor compression cycle. Clear? You have some innovative cooling system, solar operated cooling system. You have a compact system. You have a lightweight systems, and you all these have to be very, very important area of the research for the water production. So membrane-based dehumidification, I am just here putting for you. Some people are more interested for this because it has a several advantages, like a lower energy demand and compact modular configuration, can be driven by wastage heat by the space vacuum rather than the refrigeration. Already implemented in a short duration vehicles like a Dragon, all the be putting it. So it has a very, very big advantage. And IIT Mumbai, they have to be develop these systems, especially this type of atmospheric water. So I'm putting here about the IIT Mumbai, and this team is coming in our campus in 9th to 11th September. If you want to interact with them. Adsorption and desiccant-based dehumidification. So this is the area we have to be working on this. So what is our, we have like I already told you, like a click chemistry, Noida campus, they are developing a MOF. I'm integrated this MOF system in my atmospheric water generation systems, and we're making a more effective, efficient systems where we recover the 98% water from the cabins. So these are the more attractive system, I'm saying that technology, especially using like this. Like a international space station, how they have a water architecture structure. So this slide is giving a very clear picture. People are using like a chlorine, people are using a cabin air, then they do the urine process, dehumidification, then combined water, then they have to a process, then make a potable. So they have, you see in this slide, so they have to be I'm say that recover the 98% water. So 98% water, they have to recover like this. Gagarian, if you see in a Gagarian systems, so these are the all subsystems, function and special method for a Gagarian. Here, water recovery system, reclaiming the usable water, like urine, and they have to water using for a hygiene purpose. They don't use like a cabin, all these things. So this is the problem with the Gagarian. So that's they need a like a. So as I told you, Gaganyaan conditions like a 26 to 30%, all these things. And pressure is 0.13 kilopascal. This is a cabin pressure. And yes, sir. So I'm just talking to what people are doing in this area. So like IIT Mumbai, they are developed the membrane-based water recycling system. Then Amity University, they developed the atmospheric water generation, especially using the MUF type of material. And IIT Kharagpur, they are developing a hybrid humidification kind of a system. So this is the system, solar operated systems. We tested in a various under the gravity system. That has to be produce the water from the most air. We have to use these systems in a various city in India under the gravity. And for the microgravity, we have to be changes the many system here like this. If you see how we have to be, these are the videos. They show the condensation of water in a microgravity kind of system. So we have to be, now the again questions, how we have to be develop the microgravity systems. So we send this component in ISRO labs. They have to be their systems. They tested it and they say that yes, the surface is more effective and active kind of things. And here see it in the right hand side. These are the all facilities we have in our department that we have to develop a system. This is the other applications of the condensation. So like we have used the water desalination system, condensation, water quality, and Indian response. So you see that left hand side, the many challenges. Other side is the Indian response. Like we develop like a wettability gradient, porous media based condensing heat exchanger surface that can be a recover the 98% of water. Metal organic framework for water capturing. So this is developed in with association with the click chemistry, Noida, and Bharti Antranch Station toward the closed loops. That is the, you know, that target for 2035. Like we have a regenerative system, we have a indigenous environmental control, we have a thermal comfort systems, life support systems. If you see the comparative summary of dehumidification routine, system has on advantage, disadvantage kind of these things. And this type of research is still going in India. What is the key take home away? Like ISS demonstrated the 90% water recovery through the integrated of the ESLL system, but condensation supply to 40-50% is a fit. ISRO Gaganyaan established the Indian capability in a human space flight, life support development, indigenous. So we develop the indigenous systems, all these things. These are the references. You take these references and use like this. Thank you very much. If you have any questions, please welcome. No question? Good. So it means you understand everything. Thank you very much. Thank you.
Okay, so transition to session 4. Ladies and gentlemen, after exploring progressive concepts and life support system, we now arrive at one of the most exciting areas of space technology, that is rocket propulsion. So the topic for session 4 is rocket motor and propulsion systems. We are delighted to welcome Mr. Prakhar Jain, founder and CEO of Synodic Space Education. Mr. Jain is actively involved in promoting space education and bringing practical aerospace learning experiences to young minds. Please welcome Mr. Prakhar Jain with a big round of applause. Come on, everyone. Over to you, sir.
All right, good afternoon, everyone. Seems like everyone has already dulled out. That is why, sir, I preferably don't like to take the last session. Students usually dull out by the end and they're like, "Kab khatam hoga?" So honestly, first of all, let me thank to the MIT University and the MIT Institute of Aerospace Engineering, Dr. Sanjay Singh sir, for inviting me to and giving me this opportunity to talk with you all and to interact with you all. I've made a very detailed presentation. I don't know, I don't feel like taking it anyhow. I don't want to get you more into theoretical knowledge. And I have a lot of formulations in my presentation, a lot of theoretical stuff, but I'm pretty sure that you would be learning in your classes. So I have a proposition, something which I have not honestly prepared for. I brought a lot of big script and everything, but I have not prepared for what I'm proposing. I'll tell you about myself. I'll tell you about what my company does. I'll tell you about the rocket which we are launching today, which we are demonstrating today. After which we would spend half an hour where I would take your ideas and we will discuss over that. I hope that works out to you, sir, because that will give you an opportunity to validate your ideas. Because after being, in the university for more in the ecosystem for more than 6 7 years now in the private sector, uh, I prefer that I interact with the students on the basis of the ideas and not just theoretical knowledge, and that is what we actually inculcate in all the people who are working with us in the company. So let's start with first who I am. So I did my BTech from aerospace engineering with specialization in avionic systems. But later on, I found out that my interest is not in avionics. I shifted towards the propulsion side, and that is when I pursued my MTech in rocket propulsion. And entrepreneurship was always in my blood. My father is a businessman, my grandfather was a businessman, my great grandfather was a businessman. And that is why I decided that I won't join the family business, but I want to do something of my own. And I opened Synodic Space Labs. And I decided that we would be working on a private launch vehicle. Okay. So the launch vehicle which we wanted to design was for a low Earth orbit. So small satellite, low Earth orbit launch vehicle targeting the small satellite constellations majorly. Next, during the complete research and development, we found out that there's another break point and another bottleneck which we found in the space industry in India, that we are all dependent on Linux. Even ISRO uses Linux for their operating systems. Everyone in the space industry uses Linux, and that is when we decided that it's time that India has its own operating system now, where Indian companies, may it be government, may it be private, would have the opportunity uh, to showcase the world that our tech is better than this. So the entire operating system is AI enabled and everything. That is when we, uh, you know, started working on this project as well. While we were hiring people for all both of these projects, we found out that students have theoretical knowledge, but they lack skill sets. And I heard that few of you, while you were asking questions, you mentioned about these things as well. That you have the knowledge, you know what is what, but how that what has to be used in application is what lacks in the students. And that is when we decided that we would start doing space education as well, majorly just focusing on the entire practicality of each and every concept. Okay. So in the for this itself, we started and we have launched an hackathon as well, where we have industry problem statements coming from all over the private space sector, and students are being called in to work on those particular problems. And whoever has a feasible solution, they get direct access to the those private companies, including Skyroot, Agnikul, and everyone else. Well, that thing aside, let's talk about the rocket which we are launching. The name of the rocket is Trinetra TN100. The image which you can see on the screen is of TN500. Now, what is 500 and 100? 500 is 500-meter apogee and 100 is 100-meter apogee. Now, why not 500 meters here? We are not allowed to launch without ATC permission above 100 meters. Does anyone know what ATC zones are, zones defined by ATC in the airspace are? What is a red zone? What is an orange zone? What is a green zone? Can anyone answer? Like, just raise your hands. Yes. Right.
Right, it's okay. It's no problem.
And the green zone is obviously where, we can use the airspace for our commercial.
Right. So you are partially correct about the green zone. Rest both are correct. So green zone, even in green zones, you're not allowed to go above 100 meters. 100 meters is your absolute ceiling. If you want to go above 100 meters, you would have to involve ATC. You would have to inform them. You would have to take permission and create a no flying zone over whatever area you're launching in or whatever activity you're conducting. You would have to take permission from ATC. That becomes a very big challenge, especially for small private companies like us and the universities as well, whereas government organizations, it is quite easy for them. So that is one thing. So that is why I decided to go for 100 meters. It's let's keep it simple, just stick to the concepts. That was our call. So this rocket itself has its own brain. It has its own flight computer. It has its own recovery mechanism. Honestly, we are also testing one of the mechanisms. You must have heard about pyro charge based ejection mechanism. Everyone must have heard about it, that there is small blast inside the rocket body and that pushes off the nose cone and the parachute comes out. We have shifted from that. That is something which is not feasible in high altitude rockets. So we have shifted towards mechanical deployment where flaps open out, and instead of using rubber bands, which usually most of the companies do, we have shifted towards servo mechanism where a servo controls the entire flap mechanism and pushes the whatever the payload is as well as the recovery system outside the rocket. So that is what we are going to launch today. Talking about rocket motor, it is a solid rocket propulsion motor. uh, Very easy to guess that we have based it on sugar candy because that is what is easily available. You do not require licenses. Does anyone know what sugar candy is? What rocket candy is? It is a type of fuel. It is a type of propellant which utilizes potassium nitrate mixed with sucrose. Okay, so nickname of this composition is called rocket candy or sugar candy. Okay, we to increase the performance of this propellant, we add a additive which is called ferric oxide. The additive is just 1%, but that gives enough push that increases the thrust by nearly 20 to 25% and increases the ISP of the propellant as well by nearly 15 to 18%. So that is why we usually put ferric oxide. That is why when you will be able to see the propellant, it is red in color, while sucrose is white, while potassium nitrate is white, but the entire propellant is red just because of 1% ferric oxide. And it is not just light red, it's not pink, it is complete deep red, blood red in color due to just 1% of ferric oxide. So that is what we are going to use. We are using, when it comes to flight computer, we are using a ESP32 based flight computer model where the sensors, the altimeter itself is, working on the basis of pressure data coming from BMP 555. We have a BNO for all the other data. We have a IMU unit. We have other sensors. Again, my BTech was in avionics, but I'm not an avionics person. The rocket motor itself, it is somewhere around 200 long, somewhere around 45 in width, and it has a circular port. Does anyone know what a port is inside a grain? I'll cover up basics of propulsion system while talking about propellant. What a port is inside a propellant grain in rockets. All right, so the rocket motor itself, let me just use this glass. Let's say this is a circular propellant. Okay, it is not solid when it is used in rocket motors. It has a hollow hole inside it. It is a hollow cylinder. And the hollow part inside is called the port. And the shape of that hollow part is called port configuration. Okay, or port shape. So there are multiple shapes which are used in the industry, and on the basis of the shape, the performance of the rocket is determined. The performance of the rocket engine is determined. Let's say if we are using a circular port, in that case, the initial thrust would be low, and with time, when the propellant burns inside out, the thrust will go on increasing. Okay, then comes char port. That is what is used in S400 rocket boosters of PSLV and GSLV. Okay, so star port is basically a kind of design where when the burning goes out from inside out, the surface area of which is burning remains constant, and thus the thrust remains constant. Okay. Now the third is progressive burning, where we use there are multiple shapes available. We use multiple ports, and when the surface area uh, when the burning occurs, these multiple ports interact with each other, and at the end the surface area is actually smaller than the initial surface area, and the thrust itself decreases over time. So first one was progressive, then neutral, and third one is regressive burning. We are using a progressive burning grain, so initial thrust would be low, with over time it would increase, and then we would be going to the coasting flight. Does anyone knows the difference between a powered flight and coasting flight? Anyone? Anyone from rocketry, from aerospace department? How many of you are from aerospace department? Quite many. How many of you are from mechanical department? All right. So when it comes to talking to everyone, mechanical and aerospace is what focuses on propulsion part and the structural part majorly. Okay, we have defense technology. How many of you are from defense technology? Okay, so how many of you are actually working on missiles propulsion system? Have you or have studied about it? Similar concept goes in the propulsion system. Missiles and rockets are very similar. It's just the propellant is different. Okay, so what I was talking about, I get waved off quite quickly. So we were talking about rocket propulsion system itself, but we were talking about exactly the port and the burning itself. So what happens is when the port is burning inside the rocket motor, when it burns, the surface area increases inside and out, and thus increasing the thrust. When the thrust increases, we have the peak thrust at somewhere around when the powered flight is about to end. Yeah, we were talking about powered flight and coasting flight. So powered flight is where the engine is actually working. Engine is providing thrust. Okay. As soon as the propellant inside the rocket motor is over, that is when, due to inertia, the rocket keeps on going, increasing altitude, right? And that is what is called the coasting flight. So when the engine is burning, it is powered flight. When the engine is not working, it is coasting flight. It's as easy as that. So if we are targeting 100 meters, we create a rocket engine which will burn only till, let's say, 60 meters, and after which 40 meters would be coasting flight. Okay, so that is how this rocket has been designed. And this rocket was initially designed for 200 meters, but due to restrictions, we had to cap it, increase the weight of the rocket a bit. Then we have decreased the amount of propellant inside the rocket motor as well to cap it to 100 meters. Now we plan it for 80 meters and usually goes to 90 meters, plus minus 5% due to the atmospheric conditions. Okay, so that is it. That is what technical part I would cover. Now, what I will do is I will listen to your ideas, your projects, and your thought process of whatever you have in mind, and we will discuss that so that even others will have an idea of what can be done and what cannot be. Okay. So anyone who has an idea, wants to do a startup, or join any program. Yeah. Can we give him a mic, please? Yeah, yeah. Go on.
Well, sir, actually, like I have like couple of ideas, but only one idea I just want to share with you. So right now, like I'm doing my first semester, that too in defense technology. So like I'm working or yet to start the idea on like unmanned air launched decoy vehicles.
Okay.
So that is related to aerospace only, but that it has a specific defense applications. So can I just
Yeah, please
provide
explain your idea a bit.
because sir, I'm so sorry, you're from rocket background. I'm talking about a drone background, so I think there is a conflict of interest.
See, my background, as I told you, my BTech was in avionics, so we have worked on drones a lot. Plus, working in space education gives us an edge.
Yeah, sure. So basically, during Operation Sindoor, what we found out was Indian Air Force was able to destroy the Pakistani AWACS on both air and ground. AWACS is basically a mothership.
Right.
Generally, we call it as Airborne Early Warning Control Aircraft that coordinates multiple fighter jets to make them alert that enemy formation is incoming to hit you back.
Right.
So if an AWACS is lost during a war, assume that enemy's situational, informational, data-centric operations will be neutralized. They won't be able to take any offensive stance against the adversary.
Right.
So my idea was that when an Indian Air Force is struggling with the squadron strength, like depleting squadron strength and also technological industrial challenges from India, I thought, okay, why don't we use the unmanned aerial vehicle that such a way that it flies along with this AWACS and it provides protection from incoming BVR missiles, long range missiles fired by the enemy stealth aircrafts. So, for example, in a case scenario, if there is a AWACS, let's assume this is an AWACS, there are one and another decoy vehicles acting as a bodyguards, and the enemy is 300 kilometers away. So what enemy does is that enemy uses track while scan mode to target this AWACS, fire a missile in 300 kilometers, and meanwhile AWACS get a warning that missile is incoming. So immediately what AWACS do, AWACS uses data transfer and also data link to tell these drones that missile is coming, protect me. So what these drones do, they release a high amount of frequency such a way that enemy will get confused between a radar and a drone. And once the drone releases high signature, the missile will not be able to think which is an AWACS. So what it does, it directly hits the decoy.
Okay, I understood the concept which you are proposing. Sir, Dr. Sanjay, if you don't mind, can I be brutally honest? Yeah, all right. So I would be completely brutally honest with all the ideas who are gonna put them forward. Okay, this is a very cost intensive thing. Okay, putting two drones going beside AWACS, and then whenever a missile is launched over a AWACS, then the other drone comes in and sweeps in and saves the day for AWACS. Right. There are electronic warfare systems which are pre-existing in the technology, which creates multiple hoaxes around any plane, which confuses the enemy missiles itself. Okay, and giving a high chances of success to the AWAC itself. So why do you think we would require a physical object to actually protect a AWAC?
So because I'll tell you one example, sir. The research, like today morning, I was found out some research papers from Chinese People's Liberation Army Air Force Academy of Sciences. They are developing PL-17. So like whatever you talked about the electronic warfare jamming, it bypasses it actually. So I think I need to study more on that. But actually, my opinion is that we already have a target drone, sir. Like basically, as you said, like which can do that thing. But sir, when you are in a high intensive combat environment, we are talking the prospect of multi-domain operation. So you have to ensure that decoy vehicle protects the AWACS from multiple threat, not just single threat. So I'll talk to you more on this regarding this
Definitely.
information. And
Take
thank
my
you.
contact details post session, and we can have a session
Sure,
later
sir.
on.
Sure, sir. Thank you, sir. Thank you.
Thank you. Next, anyone else who has an idea who would like to discuss it? Be open. It could be anything. Yes.
Hi, sir. It's not like an idea, but I have few questions. So one is regarding startups, because we know uh, India has the largest number of startup registered recently, and we also crossed the 100 mark in the unicorns. But still, somewhere we are failing. The startups are also failing. Even in failures, we are at number one. What are the major challenges as a startup uh, someone would face? Because people are jumping directly from college to startups. So is there um, a bigger risk not understanding the corporate ecosystems? And the other thing is like, uh, what are because you have started your startup 7 years back. Back then, government of India haven't opened space sector for private companies.
Right.
What was the confidence that you took to establish a startup?
Well, I'll start with your first question. Okay. What it takes and why are so many startups failing in India and not anywhere else? In India, anyone who has an idea thinks that they are ready to do a startup. That is not the case. If you go just have an idea, even if it is the best idea available in the market, you cannot succeed with it until and unless you have a team. Okay. One person does not make a company, a team makes up a company. Okay. Second thing is perseverance. There would be many highs and lows. And honestly, 90%, 99% of the time in a startup, it is always low. You're always in a loss. And that is where perseverance come into play. Most of the people, maybe due to peer influence, maybe due to peer pressure, maybe due to parental pressure, maybe due to responsibilities, they had to, put down their perseverance, and they had to, due to responsibilities or anything else, they would have to come back to corporate life. And they, get back from whatever idea they started with and come to normal 9 to 5 job kind of thing. I'm not saying that 9 to 5 is bad. Okay. People who like work-life balance actually prefer 9 to 5 jobs, because in startup there is no work-life balance. Honestly, from past 3 years, I've not taken a vacation. Okay. And everything goes and is completely poured out into company itself. Okay. And you cannot even stop doing it. Let's take an example for the founder of Skyroot, Pawan Chandana sir. I've met him multiple times, and whenever I met him, even after the orbital launch, I met him once, and what he said was, "I don't have time to sleep," even after the orbital launch. So that is what hard work and dedication is. That is what perseverance means. So without perseverance and dedication, a startup cannot succeed, and that is what is lacking in the Indian mindset right now. Plus the parental influence and peer influence. That is another thing. So that is the major reason. Your second question was, uh, what was my mindset that gave me confidence 7 years back? All right. So initially, when I started the company, I didn't even know I didn't even know there is no space policy and private companies are not allowed. Honestly, I had no information about it, and I just launched a company that I want to do this. जो होगा देखा जाएगा. And when kept on working on it, then I had multiple meetings with government stakeholders and academia stakeholders. And that is when I got to know that these are things which are still under process. And there are no actual, protocols or treaties or whatever documentation available for uh, private startups and space startups in India. And privatization on space thing is not open yet. So initially, I thought that I would do something when I have something substantial in my hands. Then I will go to ISRO, and then they will bring me on board as in the team. But that did not work out. Okay, instead of going to ISRO, when I had something substantial, I went to the investors, and then they rejected me. Honestly, okay, we are still bootstrap. Honestly, okay, so that is when I decided that we will keep it bootstrap, we will keep it running, and we'll fund it as much as possible from our side. Okay, not from my pocket itself, but we will generate certain revenue from space education or whatever profit comes, and we'll put it in there. And that when stages like these are the stages which gives the founders and startup founders a confidence that we are doing something good, that we are able to reach from that level to this level. Because honestly, I'm not very older than you. I'm just 26 years old, turning 27 this year. Okay. So not a very long journey from that seat to this seat, not a very long time. So it feels nostalgic, but yet the dedication to become something better is what takes me forward. And that is what contributed towards keeping that dedication on when there was nothing in past.
And sir, the other question is regarding the role of 3D modeling in space sector.
3D modeling in space sector.
Yeah.
So there is nothing in space sector which can work without 3D modeling. Everything is presently dependent on 3D models itself. Even rocket engines, liquid rocket engines are now being 3D printed. Metallic 3D printing is being done on the rocket engines because connecting so many pipes outside is not a very good looking or very efficient job in rocket engines, when specifically in liquid rocket engines. Plus, there is no technology and manufacturing available which can actually manufacture those parts with such precision. So that is where metallic 3D printing comes into play. Plus, prototyping also includes everything 3D printed. Even the rocket which we are launching today, 50% of it is 3D printed. Okay, so without 3D printing, the space industry does not exist. Keep working on it if you are working on 3D printing.
Thank you.
You are talking to the 3D printing or 3D modeling?
3D printing plus mold.
All right.
Sir, sorry, I would like to add here a point. So a few months back, we had a meeting with Italian Space Agency, and 3D printing was discussed for food as well. Yes. I mean, you can have the food out there in space of any flavor, of any shape, as per your taste. And it was being discussed that 3D printer can be used for that as well. Yeah.
And I also heard that they have recently printed a hamburger using 3D printing. Yeah.
That's new thing that I learned. And thanks for that.
All right.
Thank you.
Anyone else? Come on, come up with ideas. Something. Yeah. Go on.
So this could be taken just as an idea. In 2019, 21st December, SpaceX did the launch of Falcon 9 that landed vertically right after it. So my idea is like we cannot just go directly to space and we can try what they did. But what I think is what we could do is maybe if we are doing the launching like only 100 meters and then we can try and get it back on the launch pad vertically right as it was, then we can, if it is successful, we can know that we can increase the distance at 200 meters to 500 meters to 1000 meters, and then we can finally like achieve what they did in 2019. So like, is it possible that
See,
way?
that is how prototyping works. Even if if you have seen the journey of SpaceX, even SpaceX did multiple hoppers, which jumped 1 meter, 2 meter, then 11 meters, and they have multiple altitudes which they jump the rocket to and then soft landed it, right? And you can also have a look at a company. It used to be a YouTube channel, now it's a company. It is called BPS Space. Okay. Even they have developed multiple hoppers. So these things which you're talking about is called a hopper. And that is the first stage when it comes to, building a recovery, a completely reusable rocket or completely reusable launch vehicle. That is the first step. So when you are able to build a prototype which is actually able to fly to a certain altitude, not even 100 meters, let's just go 10 meters, you take off, you hover around somewhere 10 at 10 meters altitude for let's say 2 to 3 seconds, and then you slowly come back down. If you are able to do that successfully, I'm pretty sure there are investors in the market who would put 50 to 60 crores in your startup right away. So that is something which is an essential, not a new idea, but it is an essentiality in the space industry. All right, anyone else? Yes.
Especially landing factors in booster or the winter back to Earth. So in fact, the Agricultural Cosmos people, they're working on getting back the booster back to Earth, landing down. So I think this would help definitely to provide more information. Thank you.
All right, so anyone? Yeah.
Hello, sir. Nice to meet you. My name is Mark Joseph, and I'm the president of our Aero Modeling Club. And this is Utkarsh. He's the vice president. We had a question on solid propellants.
Right.
So, our past two competitions, we had our solid propellants competitions in BHU, IIT. We have won both of them, and what we used is a mixture of potassium nitrate and dextrose. But
Right.
you have suggested potassium nitrate, sucrose, and ferric oxide. Are there other propellant mixtures that we can use, or is there any advantages, disadvantages?
See, when it comes to potassium nitrate and sucrose with ferric oxide, the casting process itself for solid propellant is very difficult because it hardens very quickly. It gives you no more than 30 to 40 seconds to harden before it hardens. When it comes to combination of potassium nitrate with dextrose, you have more than enough time to easily pour it out, then put in the mandrel of the port, and then let it dry out. It gives you in more than enough time. Another third composition which you can try out is going with potassium nitrate mixed with sorbitol. That is another combination which you can try out with. And there again, if you want to go forward with more other compositions which could be used, the chemicals are not easily available. Maybe university would be able to help procuring those particular chemicals. So you can try going for ammonium perchlorate definitely, which is commercially available only to PESOS license holders. So university would be able to help you out in that, where you would have to mix uh, ammonium perchlorate with I would just say the short forms because it would be difficult to write. You can search it on Google. It is HTPB, hydroxyl terminated polybutadiene. Then you would have to add TDI, toluene diisocyanate. Then you would have to add DOA, dioctyl acetate. Then you would have to add glycerin. So there is a complete composition when it comes to this propellant, but this is what delivers the highest efficiency when it comes to ISP readings in solid rocket propellant. And if you're working on missiles, if you want to work on missiles, go for compositions of nitroglycerin, nitrocellulose. That would give you a more homogeneous propellant, and that is what is actually used in missiles.
Thank you so much, sir.
Thank you.
Is it possible to have time with you to discuss more on this? This seems
Probably
really
after the
interesting.
session.
Yeah, after the.
Yeah.
Thank you so much, sir.
Anyone else? Anyone with any questions or ideas? Don't go out of the mind. Think outside the box. Any ideas? Won't make your university proud. Give me something which I can copy. Anyone? I think we still have 15 minutes. So I would open the round, open the floor to ask questions to any of the panelists if that is fine. Hey, do you want to go through the presentation for once? Should I? I'll just scroll out quickly. Okay, can you help me with the presentation? Bring it back to the screen. Yeah. Thanks so much. Okay, so what I initially wanted to discuss was what actually determines the rocket performance. So it is not just the rocket engine or the thrust or specific impulse itself. The entire propellant chemistry, chamber conditions, nozzle flow, thrust, vehicle delta V. The vehicle delta V is the change in velocity which is being achieved due to the performance of the propellant and the trajectory and apogee. All of these six factors play a major role when it comes to rocket performance. I'll be going very quickly. Okay, so uh, keep an eye on the presentation. So then we had rocket propulsion architecture, how solid, liquid, and hybrid rocket propulsion systems work. Okay, so again, solid has solid propellant, liquid has liquid propellant, and hybrid has one in solid and one the second one in liquid or gases. That is what hybrid is. Then there are trihybrid systems as well. Then where you have one in solid, one in liquid, one in gas. All three phases of propellants are used. They have the feed. There is no feed system required for solid. In hybrid, you do require a feed system when you have a liquid or gas into play. Then in liquid, you definitely need a feed system. Then throttling capabilities, when you talk about it, in solid rocket propulsion, the throttling capacity is very limited. As I told you, there are only three thrust curves which are easily available and easily gettable, which are progressive, regressive, and neutral. Then in liquid and hybrid, you can control throttling. You know what throttling is, anyone? Yeah, adjusting thrust, how much thrust is being produced. All right, so complexity, liquid has the most complex system. Hybrid has medium complexity, while solid rocket propellants, solid rocket engines are quite easy to manufacture. Performance-wise, thrust for solid is maximum. When you compare the ISP levels, the thrust is maximum, but the specific impulse itself is lowest for solid. Uh, Going towards liquid, hybrid has both in moderate case, whereas in liquid, ISP is highest. Does anyone know which propellant composition has the highest ISP in when it comes to liquid rocket engines? Cryogenics, so combination of LO2 and LH2, LOX and LH2. So that is what is used by the space shuttle. Nowadays, we preferably go for liquid methane and liquid oxygen combination being used by Agricola Cosmos, being used by SpaceX. Okay. Sorry about that. So storage for solid is very easy, while when it comes to hybrid, just, you know, due to the liquid and gaseous propellant which is available, it becomes a bit difficult, whereas in liquid, it is the most difficult. I would move forward now. So anatomy of a solid rocket motor, we have an igniter inside the propellant grain itself. Then we have the propellant grain, which is the entire mixture of the propellants, made by oxidizer and the fuel. Then we have insulation, which is actually there to protect the outer casing of the rocket engine. Then we have the motor case, which is the rocket engine. We have a throat, which is responsible for, you know, expansion of gases, where the expansion of gases start, and the flow mass flow rate. The throats are designed in such a way that the velocities of the particles of the exhaust gases are at Mach 1, exactly at the throat. Then we have the nozzle. It could be bell-shaped nozzle. It could be CD nozzle. I hope you all have already studied in their courses what bell-shaped nozzles and what CD nozzles are, convergent divergent nozzles are. So those are actually responsible for, you know, expansion of gases. Then you have the exit plane, where the conditions of the atmosphere interact with the conditions inside the rocket engine, and that is when we are able to get something, uh, you know, substantial. Coming to internal ballistics, the grain geometry is what matters. The burning rate is what matters. The gas generation rate is what matters. Chamber pressure is what matters, and mass flow rate and the thrust is what matters. The burn rate law, I don't know if you have already studied it or not. You would be studying it if you are going for master, if you are already student of masters. For solid rocket propellants, it is, uh, it is written as RB equals to APC to the power of n. So completely dependent on chamber pressure. PC is chamber pressure. Then A and N are intrinsic properties of intrinsic properties of the propellant itself. When you change the propellant, the A and N values changes. We have already discussed the progressive, neutral, and regressive burning part. So I explained it to you in quite easy language. Then we have combustion chamber thermodynamics. Higher the pressure, faster is the combustion, and quickly more is the thrust produced, and quickly the propellant burns. So the chamber pressure has to be maintained, balancing. There is a trade-off. You would have to balance the strength of the material which is being used to manufacture the rocket engine, plus to make sure that there is enough pressure inside the rocket motor so the combustion takes place at its full potential. Going forward to this is the most important factor when you're designing a solid rocket motor, which is characteristic velocity. Characteristic velocity is dependent on majorly three terms, which is the mass flow rate. So mass flow rate is the mass flow rate of the exhaust gases. So when the combustion is happening of the propellant, the gases which are produced, they quickly move outside through the nozzle. So the mass which is going out of the nozzle in a certain amount of time is called mass flow rate. So mass flow rate is what matters. Then the throat area. So as I told you, if the throat is more than the required size, the flow would not become sonic at the throat, and thus the thrust which you are getting out of it would be quite low, and the expansion would not be proper. If it is smaller than what is required, there would be a lot of gases inside the throat, inside the chamber itself, which will accumulate, and outside, due to that accumulation, the mass flow rate would be constant outside, but the accumulation when it is happening inside the motor might burst. So that is why you have to make sure that the throat is exactly what it should be, and the chamber pressure again. Chamber pressure is the most important part again when it comes to solid rocket motors. Coming to nozzle flow and expansion, thrust equation is what comes into play here. So thrust equation is very important. M dot VE. M dot is again mass flow rate, and VE is the exhaust velocity at the exit plane. Okay. So this is what the momentum part is. Momentum thrust is. Okay. The second part is pressure thrust, which is the second part of the rocket equation or thrust equation, which is which is written as PE minus PA whole multiplied by AE. So PE is the exit pressure, PA is the ambient pressure, and AE is the exit area. So cross-sectional area of the exit plane. Okay. So this is the major equation which you should know at least at this stage. Coming to the two most important factors when you're designing the rocket motor. One is thrust and second one is specific impulse. Make sure whenever you are working on any rocket motor design or any propulsion system, or may it be for defense purposes, you would have to make sure that the thrust and specific impulse are balanced so that you don't require a lot of propellant, but the thrust is more than enough to fulfill your mission objectives. Going to design trade-offs and systems integration. This is where a trade-off, there are multiple trade-offs which are required to build a complete rocket. So there you would have to make a trade-off in the strength and mass when it comes to structural part. Then when it comes to avionics part, you would have to make a trade-off between guidance and control. So you would be able to make sure that it is in your control, but you would have to make sure that it is unstable enough to guide it along. Then you would have to make a trade-off between drag and stability. So drag is sometimes very much required, whereas stability is very important for a rocket to make sure that it is on the right path. Then there would have to be a trade-off in the thermal management itself, that it should not be too hot, it should not be too cold. Then there is a major trade-off between payload and orbit. So higher the amount of the payload is, lower the orbit you would be able to achieve. So you would have to make sure that you are able to optimize that. Then in propulsion as well, there is a trade-off between thrust and specific impulse. Higher the thrust, lower the specific impulse. Okay, so these are the major trade-offs. Going to solid propellants and motor designs, I have already discussed about the various shapes. We can go for multiport, we can go for tubular, we can go for rod and tube, we can go for star, which is actually used in this industry. So again, this is theoretical, so I'll skip this part. Combustion and performance limit. So performance limit is again very much dependent on the intrinsic properties of the propellant itself. If the propellant is not actually able to uh, give you high calorific values, so the performance itself would not be very high. That is why when the Rocket Aero Modeling Club asked me, I suggested that if they want higher performance, they can switch to higher level propellants. But again, they are very much controlled by the government, because same propellants are actually used to make time bombs and bombs as well. Okay, so TNT is also made out of it. Going to next slide, material structures and thermal management. There is a lot which is written on the presentation. I'll send the presentation to the administration and they will share it to you if anyone wants it. You can just get my contact details and you can get the presentation from me. Then the rocket system and avionics. We have the payload in the rocket itself. We have avionics bay, we have the structure, we have the propulsion system and the recovery system. All these 5 components make the entire rocket. Then this rocket is actually which can be launched. Without even one component, the rocket would be a complete failure. Moving forward, the mission design and trajectory analysis. This is a very important part, and this is something which you should listen to. Designing a rocket, everything is done. But if you don't have a proper trajectory planned out, the mission objectives might not be met. So that is why even after designing the finest rocket, orbital mechanics is what comes into play to finalize that this mission would be a success even after using the finest rocket. So trajectory planning is very much important. Then comes the mission design. So at what stage what will happen? When will the first stage separate? When will the second stage separate? When will the third stage separate? Let's say if it is a single stage rocket, when will the parachute be deployed? When will the payload be deployed? So that is something which completely comes into the mission design part and trajectory analysis part. Okay. Moving forward, the launch operations and mission execution. So launch operations just not pressing the ignition button and the rocket is a go. You would have to do multiple tests. There are multiple checklists which you need to follow. You would have to make sure that all the systems are switched on, all the systems are working fine. You have live data communication if you are using it. So the live data is directly being transferred to the ground control station. You would have to make sure the propulsion system and the ignition system is working fine. So you have already done the static testing of the rocket motors. I know that everyone knows that it was a success, But even after that, there might be a few chances that the rocket propellant itself might fail. Let's say due to the casting, because casting is something which is not necessarily same every time. There are definitely few changes every time, and that is what will affect the mission success of a, which will bring the results that and tell you that if the mission is going to be a success or a failure. All right. Moving forward, the big picture and way forward. We have already explored a few ideas which you guys told me. If you have any more ideas which you were not able to put in public but want to explore or you want to touch base with, you can contact me directly. You can get in touch with me after the session, and I'll give you my contact details, and we will have a schedule a session to discuss it. Thank you so much. That was it from my side. I'll take a few questions if you have any.
So actually, when we designed the rocket that we actually made, so we made the stability around 1.8 calibers.
Right.
And when it went up because of the mass flow rate outside, the stability significantly reduced, and the rocket was supposed to go straight up, but it didn't went that way. So what can
Okay.
we do for that?
So so again, 1.8 is a a good stable rocket. So 1.8 stability margin is completely fine. Numerically, it is fine. But when the rocket motor burns out, the weight, the CG itself shift towards upside. That will reduce the stability. So you would have to make sure even when the motor is completely burned out, your stability margin at that even at that point is above 1.5. What's it?
Burning of fuel, CG will put in the forward bar.
Yes.
Stability will improve.
The stability will decrease.
Static margin.
See, it again, it completely depends on how the rocket is designed. Even a overstable rocket is not good for a launch. Right.
Will depend on the distance of fence with the CG.
Yeah, so basically the distance between CP and CG. Right. Definitely. So again, Sir's point is also correct here. But even an overstable rocket is not good for our mission objectives, because when the rocket is when the rocket becomes overstable, that is when weather cocking comes into play. So even a small wind or gust of wind would change the direction of the rocket completely. So the even when the rocket is launched and at the burnout point, the rocket should have a stability no more than 2.5. Okay.
No more than
2.5. And no, at any point in the flight time, the stability of the rocket should not be outside the range of 1.5 to 2.5.
Okay, sir. Thank you, sir.
Anyone else? Any questions? Yes.
What is your take on aerospike nozzles?
Aerospike nozzles are something which are gonna definitely going to happen in future. That is the future, because the specific impulse in the aerospike nozzles significantly increases, plus the flow which is going to happen, which for due to which aerospike nozzles are being used, the flow, so that the flow keeps stuck to the nozzle itself, the nozzle surface itself. For that purpose, aerospike nozzles is really good. But honestly, what I believe is direct use of aerospike nozzles might not happen even in future. There might be a play by changing the shape of it and making it a truncated aerospike nozzles. So truncated aerospike nozzle is something which might come into play, and that will become that would could be commercially used in future. And there was even you might have heard about an AI designed rocket engine which was recently tested, right? So AI completely designed a rocket engine. That was a aerospike nozzle. Even that was a truncated aerospike nozzle, not an aerospike nozzle itself. So truncated aerospike nozzle is what I see future in.
Because of the high temperatures, even material makes.
Exactly. Due to the structural limitations. Yes.
Thank you.
We are having solution for that. It's the altitude compensation also. Truncated is just for reducing the heat flux. So we are having solution for that. It's the altitude compensation also.
Thank you, sir.
Yes.
Physics evaluation. Which model you are using?
So we have a collaboration with a company called Boson QPI. So boson cube pi basically have quantum based algorithms which they run through various data sets which they have developed over time and collected from multiple organizations from all over the world. So whenever we have something of the parameters, initial parameters in place, we give them our parameters and they analyze multiple situations which might happen. And we also give them the final objective of the rocket, right? So on the basis of the final objective, they do multiple runs, and due to the algorithms we are running, which they are running, and I don't know what is going on behind the stage in their technology, we are able to see what is the worst case scenario, the best case scenario, and the ideal scenario. Simulations is what.
Sir, actually, that the low Earth orbit is completely filled with all the satellites, and now it's been
Right.
my primary importance.
Right.
Now, the Indian startup like Bellatrix Aerospace, they're getting into the very low Earth orbit. That means from 100 kilometers height above the sea level, and especially when you're talking like when we are talking about very low Earth orbit, there is still an atmospheric minimum conditions over there.
So are you sure you're talking about Bellatrix or are you talking about Pixel?
Bellatrix, sir.
Bellatrix is responsible for making Hall iron thrusters, and they basically develop electric propulsion systems for satellites.
Okay, so I'm talking about that regard only because they are planning to develop a dedicated or a propulsion system
Right.
to let the satellites to work even in the lower orbit, very
Right.
low Earth orbit conditions. So basically, sir, me and my friend last year when I was doing my BTech, we worked on RD engine, sir, rotating detonation engine.
Right.
So do you think that RD engine is gonna be the next elapse, or you can say the next innovation wave for the powering very low Earth orbits in future RD
See, there are
engines?
multiple technologies which are available in the market conceptually right now. And all of these technologies which are conceptually available in the market might not be feasible right now, but maybe in future, right? Because of structural limitations, because of weight limitations, because of technical capability or manufacturing limitations, or due to multiple limitations, these things might not be possible right now, but would be possible in future. Like the RD engines which you have seen working, they were not something which would have been possible in 2010s, but right now they are something which they have been experimenting on. Similarly, when it comes to nuclear rocket propulsion, this is some nuclear rocket propulsion is something which is not feasible as of now due to the heavy weight of nuclear reactor itself, which has to be carried, right? So the payload capacity itself decreases. It's better to financially more feasible to launch a chemical rocket propulsion instead of nuclear rocket propulsion. So again, when these limitations break off, the future technology would definitely come into play.
So like you mean like still we are in the TRL 1 to TRL 4 level. We haven't crossed the sufficient maturity in those technology, right? That is what you're
Yes.
saying.
So RD, I don't think so. We are over TRL 4 right now. We are still in testing phases.
Testing phase, okay.
Right. Again, in nuclear propulsion, there was a program ran by NASA, but they shut it down ultimately. So even they decided that this is not something which they would like to pursue right now because of financial feasibility again. It is very expensive.
The nuclear propulsion with the BRC. So important. Another is rotary differential pressure gauge. That's the work is going on. It's a good area. If you're interested, you can start work.
Got it, sir. Thank you, sir. Thank you.
Thank you so much.
Thank Yes, sir. Yes, sir. Sure, sir.
All right. Thank you so much, everyone. That was it. Looking forward to seeing you during the launch demonstration. Thank you.
Thank you, Mr. Prakhar, for your engaging and informative session on the science and engineering behind rocket propulsion systems. I now request Dr. Sanjay Singh, sir, Dr. Shafali Kashyap, ma'am, to kindly formally felicitate our technical partner, Mr. Prakhar Jain, founder, CEO, Synodic Space Education. A huge round of applause for Mr. Prakhar Jain. Before we proceed towards the practical understanding of the rocket system and the live rocket launch demonstration, we formally conclude today's workshop as we have traveled intellectually from Earth to space, exploring rockets, human spaceflight, artificial intelligence, digital twin technologies, quantum systems, etc. On behalf of Amity University, under the dynamic leadership of our Honorable Founder President Sir, Honorable Chancellor Sir, and respected Vice Chancellor Madam, in collaboration with Indian Space Association, we extend our sincere gratitude to all our esteemed speakers, faculty members, and participants for making this event a grand success. Also, thanks to Dr. Shifali Kashyap, Senior Additional Director, Amity Foundation for Science, Technology, Innovation Alliances, for their efforts to make this event possible. Our sincere thanks to the administration, IT, media, and ASCO department for their constant support in conducting the successful event. Our sincere thanks to the engaging participants and the audience over here. We invite you for the tomorrow's panel discussion as well, going to be held at F2 auditorium, wherein you will have an opportunity to interact with the dignitaries of Indian Space Association and our other industry partners as well, like Utelset OneWeb Communications and Sohara Technologies. Thank you so much for being such a wonderful audience as well.
Thank you, Kamakshi. So, dear participants and esteemed faculty members, so comes the moment now many of us have been eagerly waiting for. So, we are about to witness the live rocket launch. And before we proceed, I request everyone to carefully follow the safety measures provided by the organizers. So, let's get ready to experience the thrill of aerospace engineering in action. So let's proceed to the main ground of university campus and then see the live telecast. Okay, thank you so much.
चलो बेटे इधर पहुंचिए। चलो सब लोग इधर पहुंचिए। हाँ भाई, हो जाओ।